You see, when you examine the earth and all of the design elements, you realize that somebody built the earth. The question then becomes, who built the earth? Upon the planet Earth, we as human beings like to build things. We build cars, we build airplanes, we build cities. Within the cities we build buildings. We have tall buildings, we have houses, we have apartments. We build factories. We manufacture things. We manufacture clothes. We manufacture tools, wagons, glasses. We make things. We build things. We're builders. We are builders. We are a builder race. By the same token, our ability to build is still not at the highest level. If we look at history, prehistory, we have learned to build things, right? From the wagon to the car. We have built things. 200 years ago, there were no airplanes. So somehow we learned to build an airplane. If you ask somebody 200 years ago, the concept of an airplane, they would not understand it. We build smartphones, basically handheld computers. If you were to show a handheld computer to the people on Earth 2,000 years ago, they would say it's magic. It's from the celestial beings, the divine creators, or from God. They would say this device is from God. And then they look in the device and say, these are the angels. So we can build things, but also what you build may not be understood by our ancestors. By the same token, what our future children will build, we may not understand, or your parents may not understand. Your parents may not understand how the computer works. Only now they may be using a handheld PC tablet after hours of explanation. It's a foreign thing. There's something happens to our memories. Something happens to it when we introduce things, when we remove things. So we can build things, we have technologies, we have abilities to manufacture. And some of them are pretty impressive. We can build a bridge. I don't know how to build a bridge. If I were to look at a bridge, I would say that's impressive. Like I couldn't do it. And yet it's there. So logically, right? Logically, I see a bridge. I cannot build a bridge. I do not know anybody who can build a bridge. But I see the bridge and I say, it is there. So someone built it. That's my logic. And because we know that there are architects who design bridges, and there are people, workers, and designers, and engineers who can build a bridge. We know that. Even we don't know them personally, we can infer, we can accept the idea that there are these people because there are bridges. There's a bridge, somebody built it. No one says that bridge is natural, right? No one says the Golden Gate Bridge, oh, that, God made it. No one says that. Well, maybe some people, but, one or two people in the world. But the majority of people, no one thinks that is natural because it's made out of metal. It's got design. It has design features, right? When you look at art, there's an architecture. There's a design feature. There's a purpose to the bridge. It spans one area of land and it goes across, right, to another area of land. It spans two distinct pieces of land. It is flat to allow the transportation of vehicles, right? It's not natural that the road across the bridge can allow a vehicle, a truck, a bicycle, a motorcycle to go over the bridge. You're following me, right? There's a design, there's an architecture, so there's someone who imagined it. There are design principles, there are engineering principles, that the bridge doesn't break, that the bridge during a storm doesn't shift, that, we know land rises and sinks according to the flow of water, according to the shift of the tectonic plates. So land is shifting. So when they built the bridge, they had to take into account that the bridge is going to shift. Even though by perception, by the naked eye, we cannot see the shifting. But the designers, the engineers knew that the bridge would shift. And they built in mechanisms to allow the bridge to shift. So otherwise it would break. And as well as when the bridge shifts, the plates, right? The plates connecting the bridge, they have to shift. So the bridge is shifting. The bridge is shifting like that, right? Back and forth. Depends on the storm. If there's an earthquake, the bridge has to have that mobility, that utility. We don't think about it, but when you're on the bridge and there's an earthquake, you can see it shifting. Well, the architect put in mechanisms, and the engineers created mechanisms so that the bridge wouldn't break. And that shows you, again, it's not natural. How do we know it's not natural? Well, we can see it's not natural. It's made out of metal. It's painted, right? But we can also see the design, the architecture, the engineering. If you're an engineer, if you understand engineering, you can say, well, you can see more things than I'm going to discuss. There are, the balance of the bridge and the weight, and you have to look at the metal, how much metal they use, what kind of metal, what's the purity of the metal, right? What's the paint? Was it a certain kind of paint that resists oxidization? Was the metal treated to prevent rust? All that we can get into the fine details depending on our experience, on our expertise. If we were engineers, we can get into all kinds of metrics. We can get into numbers, right? Angles. The bridge is built at a certain angle, 23 degrees. And that's all part of the design. The 23 degrees is because cars will be able to climb at that rate without any interference. And if there's ice and snow, it still will be able to climb. All of this is in the design of a bridge, of a simple bridge. So where am I going with this design, this building? Well, when we look at the Earth also has design features. The Earth also has architecture. Architecture is something that is inherent in the design that is too perfect to be natural. So we look at the atmosphere. Look at the atmosphere. Human beings need a certain amount of oxygen in order to breathe. It's 20-something%. So there is enough oxygen for me to breathe. And if there was a less oxygen, I would not be able to breathe. If there was more oxygen, I also would not be able to breathe. The human body is designed to breathe oxygen at a certain percentage. That exact percentage, given the fact that each human being processes oxygen a little bit differently. Each human being, depending on their health, will process oxygen differently. So there's this variance. Just like the bridge. The bridge got to be able to shift. Right? The bridge has got to have these mechanisms. So the human body can exist on a range of oxygen, but it's a very narrow window. And all human beings, all animals have that ability to process oxygen. And that happens to be the exact ratio right here on the earth. It's a very simple thing. It's something that you can dismiss. It's not something you think about. We take oxygen for granted. Oxygen, we take you for granted. Because it's an expectation. I need it. I cannot live without oxygen, therefore you have oxygen. But the exact ratio, when we see this exact ratio, there's a design element. So someone designed it. You look at the atmosphere, right? The air, the atmosphere. There is an atmosphere around the earth that contains life. Contains oxygen, carbon dioxide, nitrogen for the plants, and all the other elements are contained with this invisible barrier called the atmosphere. Now, if the atmosphere were to go, then we would lose our air and we would all become extinct. So there's an atmosphere. The atmosphere also maintains the perfect balance of oxygen and carbon dioxide and nitrogen, because we know that humans breathe in oxygen and they breathe out carbon dioxide. Consequently, or luckily, trees, plant life, breathes in carbon dioxide and breathes out oxygen. Just by chance. Total natural chance. No. No. That's not chance. That's not nature. That's not even God. That's design. That's engineering. When they engineered the atmosphere, they built in these elements. They built in these chemicals to keep us alive. To sustain life, we need oxygen. We need carbon dioxide, because plants need carbon dioxide to produce oxygen. If there were no plants or trees, no plants or trees, and you'd have humans breathing carbon dioxide, there'd be too much carbon dioxide. And the climate change people would just go crazy, because we would die of excess carbon dioxide and oxygen would be depleted at some point. right? So we need plants. We need the ocean. The ocean also can store carbon dioxide. And elements in the earth can store carbon dioxide. So there is a very unique balance between all of the elements in the air, and that's contained by an atmosphere, and that's all design. So who would build these into the earth? Who would plant trees? Well, who would create these trees? Who would design these trees? Who would seed these trees? Enough trees that the planet could carry life, that the planet could be inhabited by lots of people. There are plants. There are frozen cores in the Arctic and the Antarctic, the poles, the two poles. The two poles are frozen, and they can melt and they can freeze according to historical patterns. They have gone through freezing and they've gone through melting in order to keep the balance of the earth. There's a magnetic system. The poles are magnetic. When you point a compass, the compass will point north because it's magnetized. So there's an electromagnetic field within the earth. That's not natural. There's a design. You see all these design elements. The earth is a very large piece of real estate. And it's in this solar system. Solar system is basically dead space. Life cannot exist in space. There's no oxygen, for example. So the planet, protected by an atmosphere, this giant ball of rock with water on it, and the water doesn't pour out. This giant ball of rock with water on it is spinning, is rotating quite fast, and it's also orbiting a bright star, a ball of fire, right? The planet is rotating, and it's off axis. It doesn't rotate perfectly. It rotates a little bit off, right? The axis, the axis of the Earth is not always exact, so it's kind of wobbling. It's this wobbling planet that's orbiting a bright star at 70,000 miles an hour. We're like this, we're whipping around a giant star. So we have these design elements in the earth. The fact that the earth is round. The fact that there are trees. The fact that there is water that sustains life. The fact that there is food that grows in the soil that we eat. The fact that there's air, the fact that there's an atmosphere, the fact that the earth must rotate at a certain speed and a certain degree on the axis. There's a degree that the earth rotates on the axis, right? So it's rotating, it's wobbling. The earth wobbles, right? So there's a design. That's engineering. You got numbers, you got degrees, and you got the speed of rotation. And then it's also orbiting. So you got this wobbling Earth. It's also orbiting a star at 70,000 miles an hour, which is pretty fast. We don't think about it. We take it for granted. We take the air for granted. I need air. You don't say thank you to the oxygen. We got all these design elements. So in the solar system, there's this galactic piece of real estate that by all measure shouldn't be there. It's like a bridge. You see two pieces of land and the water, and there's this bridge. That bridge is not natural. My first thought, that bridge is not natural. That bridge shouldn't be there, but it is there. It is there, therefore someone designed it. There's an architect. Someone built the bridge. Same with the Earth. This wobbling planet racing around the sun day in and day out, month in and month out, 70,000 miles an hour. It's pretty fast. Someone built it. You see, when you examine the Earth and all of the design elements, you realize that somebody built the Earth. The question then becomes, who built the Earth? Who has the knowledge and capability to build a planet? I don't. I don't think you do. I don't think anybody on the Earth that is human can build a planet. Not yet. Maybe 1 billion years from now. Right? How old is the Earth? The Earth is 4.6 billion years old. How old is the Sun? The Sun is 5 billion years old. So someone built the star or created it. And then someone put the Earth here. Someone built the Earth. So the way I understand it, the way I interpret it, and what I've learned is that the Earth was built somewhere else. And then it was brought here and put into the solar system, put into this environment. And then later, it became populated as a space colony. It was colonized. It was terraformed. For however many thousands of years that it goes back. Now, the Earth is 4.6 billion years old. And apparently, allegedly, it's been here for that long. That is an interesting concept. But that's way beyond our ability to understand. We cannot understand the technology of a race that could build a planet 4 or 5 billion years ago. Right? That could be a race of beings that can live for 1 billion years. Right? How long does it take to build a planet? How long does it take to create a solar system? How long does it take to create a star? We're talking about tens of thousands of years, right? Sometimes. The formation of these particles, right? Interstellar particles. The building of a star, the heating up of a star, and to build a planet, and to bring the planet from another solar system, another galaxy, and to bring the planet and to stick it in orbit such that the electromagnetic fields will carry this thing endlessly. Because the Earth doesn't slow down, right? Don't you think that the Earth would slow down after 1 billion years? Wouldn't it slow down? Right? There's a design element. That's a science that's well beyond our science. That the field is so strong, the field of the sun. I'm not an astrophysicist. I don't want to get into the details of astrophysics, but I want to convey the fact that there are design elements. That this Earth has been going around the sun for 4.6 billion years, and it hasn't slowed down. Hasn't slowed down enough to stop. Because if it slows down, if the Earth slows down, it's going to fall out of orbit, right? Has the Earth ever fallen out of orbit? Right? It has to maintain a certain speed. It has to maintain a certain wobble. It has to maintain a certain atmosphere, oxygen. Over thousands of years, oxygen changes, the icebergs melt. All of that has remained constant for tens of thousands of years to sustain human life. Because somebody built it, somebody designed it, and someone is maintaining it, which is my other contention. Someone has to maintain the planet. When you buy a car, you have to do maintenance. Otherwise, the car starts to wear down. Parts start to break, parts wear out. You have to maintain the vehicle. You have to maintain your house. You have to maintain roads or they get holes, right? You have to maintain an airplane or it won't fly. Same with the planet. Again, it's a different technology. We're not going to get into the maintenance of the planet, but it's going to involve energy. It's going to involve electromagnetic energy. It's going to involve technologies that can maintain the atmosphere. That if there's too much CO2, if there's too much oxygen or not enough oxygen, if there are too many chemicals. There are certain structures built into the earth that look natural, that I think, and this is my theory, that assist the earth, that maintain the earth. For example, I would point out a volcano. Volcanoes are mechanisms, tools, devices that assist in the earth's evolution, assist in the maintenance of the earth. If you look at what the volcano produces and how it can bring about balance to the earth, and it's a release of pressure. It's when it spews out things, the plume, that's carbon, right? It's full of carbon dioxide. That interacts with the atmosphere, that flows around the planet, that gets captured into the ocean. That's all part of the recycling. That's all part of the maintenance and recycling. When the earth goes out of balance, a lot of volcanoes start to go off, a lot of earthquakes, because the earth is shifting. Like the bridge is shifting. It's built into the bridge. The earth, the tectonic plates are shifting. That's a design, right? That's to allow this shifting of the earth. When there's too much pressure, the volcano erupts. Otherwise, there'd be too much pressure, and that would cause collapse, that would cause breakage. When you get into the, geography, and you get into the, natural formation, there's design in it. We can't cover that in the video. But when you look at things, right? The type of trees that grow here, the food, the fruits, the type of animals we can eat, the type of animals we cannot eat, the type of animals that kill other animals, the type of birds that kill insects. All of that, we can keep going. It's a design. There's an architect. Somebody built the earth. These are very advanced engineers. So advanced that we will never meet them. We might meet some of the maintenance crew. Some of the maintenance crew may be around. But the engineers, the builders, they're off building other planets. There's something that we cannot understand. Especially until we understand that the Earth was built. That's the first step, right? That's the first step. Somebody built the Earth. It just didn't pop up in the middle of a solar system with such perfection. And if you go around the galaxy and other galaxies, you'll find more habitable planets, which astronomers are finding, and someone built those. So we build buildings and cars and cities, and some people build planets.